is a reference mismatch?
When operating under normal conditions, systems equipped with internal, oven-controlled internal oscillators provide highly stable and synchronized reference outputs for both black and burst, tri-level sync, digital audio, and precision time protocol. This stability is achieved by locking each oscillator to a common global navigation satellite system reference, ensuring phase alignment across all timing domains. In the event that the GNSS reference is lost, each device transitions into holdover mode, relying solely on its internal oscillator to maintain timing stability. Although these oscillators exhibit excellent short-term frequency accuracy, they are not phase aligned with each other. As a result, while each reference continues to operate independently with minimal drift, the overall system loses synchronization between black and burst, digital audio, and PTP. This mismatch can manifest as frame sync errors, video phase offset, or lip sync discrepancies, particularly in hybrid SDI and IP environments where precision timing correlation is critical. The simplest way to ensure that your NTP, black and burst, tri-level sync, digital audio, AES, EBU, and PTP remain synchronized is by having all reference sources generated from the same oscillator in your sync pulse generator, and that unit is locked to a GPS reference. That way, if the signal pulse generator loses its GPS reference, both NTP, black and burst, tri-level sync, digital audio, AES, EBU, and PTP reference will use the sync pulse generator's oven-controlled internal oscillator and go into stay in sync mode. And when the GPS reference returns, a slow lock function is available to eliminate the shock that occurs when the gen lock is performed again based on stay in sync. This makes it possible to construct an extremely reliable synchronization system.
In larger systems that employ redundant LT4670 units in combination with an LT4448 emergency changeover unit, additional failure scenarios can arise. These can introduce conditions where the black and burst, tri-level sync, and PTP reference sources end up coming from different LT4670s and causing reference signals to drift out of alignment, resulting in a reference mismatch.
Test number 5, change of Grandmaster.
In hybrid IP and SDI environments, both the traditional analog black and burst, tri-level sync, digital audio, and SDI reference signals, along with PTP, will come from the same LT4670. Now, should an event take place that causes the best master clock algorithm to select a new Grandmaster, we could have the position where analog black and burst, tri-level sync, digital audio, and SDI continue to come from the primary LT4670, but the PTP has selected a new Grandmaster, that being the backup LT4670. And this change can occur for a number of reasons. Maybe there's an issue with the GPS reference causing the clock class to change. Maybe there's adjustments made to priority 1 and priority 2 values. Or it could be a link connection within your system that causes the best master clock algorithm to select a new Grandmaster. To help overcome this, Leader has introduced a new LC-2185 cable, which connects to both LT4670s and the emergency changeover unit LT4448. So all three devices are aware of their condition in relation to both PTP and traditional SDI references. So with the new cable connected, version 3.0 software adds the ability to link both your black and burst and your SDI outputs to PTP1 and PTP2 best master clock algorithm. Version 3 also includes the ability to link to the changeover. So here we have a scenario where there is a reference mismatch. The best master clock algorithm has selected the backup LT4670 as the Grandmaster because it still has a GPS reference, whereas the primary has lost its reference and has therefore changed from clock class 6 to clock class 7. With the new software and cable installed, we can now have the primary LT4670 introduce a failure on the analog black or SDI, which results in the emergency changeover unit becoming active. And that results in it switching so that now your traditional SDI references, analog black and burst, tri-level sync, digital audio, and SDI, now come from the backup LT4670. So let's take a look at the LT4670 operating in this mode. And to start with, I'm going to select black and I'm going to go to link PTP1 to the best master clock algorithm. So now, if any changes take place and the best master clock algorithm selects a new Grandmaster, the emergency changeover will notice this. So when the GPS reference is lost, the 4670 goes to stay in sync, and the changeover unit, the LT4448, spots an error on the black output and switches the traditional black and burst tri-level sync outputs from the primary to the backup. And you'll also notice that the Grandmaster ID has changed on the LV5600W from 73 to 75. And all this happened automatically, thus ensuring that your traditional black and burst, tri-level sync, SDI and digital audio references and PTP continue to come from the same LT4670, so there is no reference mismatch on your system.